In this video, we're going to look at the multiplication rule a little bit more. Specifically, we're going to talk about conditional probabilities some more and complements a little bit more. We're going to talk about complements in the context of probabilities where we are trying to find the probability of at least one of some event. And so let A be the event where you get at least one. Then a complement is the event where it is not at least one. If it's not at least one, and the kinds of things we're going to look at, that's going to mean that, we get 0 or none of something. You get nothing. So that is the complement. We want to find the probability of that complement, the probability that we get none. And then we will use the complement rule and subtract the probability of the complement from 1, and that will leave us with the probability of A. Right? So probability of A is 1 minus the probability of its complement. The idea here is getting the probability of 0 that you get none. That is an easier thing to calculate. Because that is easier than taking 1 minus that will be easier than going through all the different ways where you could get at least 1. So let's look at this example again. Here we have a sample of 700 American internet users, age 18 to 24, found that 546 were Snapchat users. What is the probability that 3 people randomly selected from a sample without replacement has at least one Snapchat user? So the probability that none of those 3 use. We found in our last video, we found it to be 0.0106. You can look back to the last video to see how that was calculated. So now if we want to find the probability at least one of them uses, we will take 1 minus 0.0106, which is 0.9894, or 98.94%. If you randomly select 3 people from this group, there's a 98% chance, almost a 99% chance, that at least one of those 3 people is going to use Snapchat. Is it possible that all 3 of them do not use it? Sure. There's a 1% chance that that happens, but it's pretty unlikely. 98% of the time, it's going to have at least one of them using. Perfect. Next up, we'll look at the conditional probability. So the conditional probability of an event is the probability that an event occurs given that another has already happened. We've already looked at this before, talked about it briefly. We use this vertical line for that given notation. As a formula, we can calculate this as the probability of A and B divided by the probability of A. All right, so we'll go through an example. In this example, that formula works. We're going to avoid using the formula. We're going to use a little bit more intuition and think about what does this conditional probability mean? What is it saying? So here we have employees at a company are tested for drugs. The results are shown below. Positive test indicates a drug was used. We want to know what's the probability that a randomly selected person does not use drugs given they had a positive test, and the probability that a randomly selected person has a positive test given they do not use drugs. Right, so we're going to look at a variety of things here. So our first value that we have is, what is the probability a person tested positive given they do not use drugs? So if we are given that they do not use drugs, that means that we are restricting our attention to those people right there. There are a total of 950 people in this company that do not use drugs. From those 950 people, we want to know what's the probability they tested positive. So when we know that we are part of those highlighted blue values, only 99 out of those 950 tested positive. So this is something like 0.104 or 10.4%. So for all the people that don't use drugs, 10% of them had a drug test that came back that said, yeah, we think they used this drug. The second part is we want to look at what is the probability they do not use drugs given they tested positive. So here we know they tested positive. So they're part of those 140 people here. So from those 140 people, how many tested positive? How many did not use drugs? And it's those 99. So 99 divided by 140 gives us 0.707, which is 70.7%. Notice these two values are not the same. So that order of that given, it matters. Also notice the second one says, if we know that someone tested positive for this using this particular drug test, 70% of the time that person did not actually use the drug. So if we had a company and we fired everyone that took this drug test that tested positive, 70% of the people we fired would not have actually used the drug. Also, when we administer this drug test, out of all the people that don't use drugs, 10% of the time you're going to get a false positive. All right, so that is how we can calculate some conditional probabilities and some at least one probabilities. We will talk to you next time.